Namaste everyone.
Namaste, sir.
Namaste, sir.
Namaste, sir.
Namaste.
Namaste everyone. Have your video switched on everyone, please. My humble request. Yeah. So today we are going to start with the next chapter. It is actually the first chapter in your 10th maths, that is real numbers. Okay. So first of all, we are going to discuss some basic concepts. Okay. Just focus. Lot of your doubts and like whatever confusions you have will be cleared. Okay. So just keep listening. Okay. So in this chapter, real numbers, first of all, we are going to discuss some number systems. Okay. The first in that is nothing but natural numbers. Okay. Natural numbers. Okay. So what are natural numbers? Natural numbers are nothing but counting numbers. Okay. The numbers which we count, they are actually called as natural numbers. So natural numbers are nothing but, I can say, they are counting numbers. Natural numbers are nothing but counting numbers like 1, 2, 3, 4, 5, and so on up to infinity. What is infinity? Infinity is a very large number. Okay. So what are natural numbers? They are not, natural numbers are nothing but counting numbers like 1, 2, 3, 4, so on up to infinity. What is this infinity? It's a very large number. Okay. Now, the collection of the numbers starting from 1 and going up to infinity, we represent by this symbol. Okay. We have one symbol to represent a collection. We use curly braces like this. We use curly braces to represent a collection. Okay. So when you put this in curly braces, it means it is a collection of numbers starting from 1 and going up to infinity. So collection of numbers starting from 1 and going up to infinity is actually called as natural numbers, and we use capital N for that. In your higher classes, you will be learning a chapter called as sets. Okay. In your higher classes, you learn a chapter called sets. So in that chapter, you will be just using letters, capital N. Capital N means what? It is a collection of natural numbers. Okay. So wherever capital N is mentioned, you should just remember that it is a set of numbers starting from 1 and going up to infinity. Okay. So wherever capital N is mentioned, you please remember it is a collection of numbers starting from 1 and going up to infinity. Okay. My voice is audible, right? Agna, you please check your, volume. My voice is very clear, I think. So there should be no issue from my side. Okay.
Yes, sir.
Yes. Okay. Okay. So we have understood what is natural numbers. Okay. This symbol is actually called as, if anyone doesn't know, it's actually called as infinity. Infinity means what? Very large number. Okay. Next, we have something called as whole numbers. Okay. Whole numbers. Whole numbers. See, the collection of all the numbers, all the natural numbers, including 0. 0 plus the natural numbers becomes the set of whole numbers. Okay. So if you have 0, okay, if you have 0 along with the natural numbers like 1, 2, 3, 4, 5, 6, 7, like that up to infinity, the collection of the numbers starting from 0 and going up to infinity is nothing but whole numbers. Okay. One more thing you remember, that all the natural numbers, see all the natural numbers, these are all natural numbers, right? all the natural numbers are whole numbers, but vice versa is not true. I repeat, all the natural numbers are whole numbers. See, 1, 2, 3, 4 are natural numbers. They also belong to whole numbers, right? Because in whole numbers we have 0 and natural numbers. So all the natural numbers are whole numbers, but vice versa is not true. All the whole numbers are not natural numbers. 0 is a whole number, but it is not a natural number. 0 is a whole number, but it is not a natural number. So please remember, all the natural numbers are also whole numbers, but all the whole numbers are not natural, because 0 is a whole number but not a natural number. Yes or no, everyone? Yes. See, if you are able to understand, show a thumbs up. Yes, thank you. And if you're not able to understand, you can put capital R in the chat box. I'll definitely repeat. Okay. These are all very simple concepts you have already learned in lower grades. Okay. Agna, you tried to join using a different device. I mean, I have actually, my voice should be very clear. Okay. I can join through another device and show you. I don't think so there should be any issue with the microphone. Okay. I am actually using this microphone. Okay. I don't think so there should be any issue. Okay. You check your device once. Okay. Next we have integers. Okay. So we have learned what is natural numbers, what is whole numbers. Next we have integers. Integers are the collection of numbers which includes 0. Okay. Positive numbers like 1, 2, 3, 4, 5, 6, 7, 8, like that up to infinity. And negative numbers as well. Like -1, -2, -3, and so on up to minus infinity. Integers are the collection. They are also collection of numbers which includes 0, positive numbers, as well as negative numbers. Okay, so collection of all these numbers is referred to as integers. See, for natural numbers, we use capital letter N. For whole numbers, we use capital letter W. For integers, we can use capital I or Z. See, this is actually in now in recently published textbooks or even JEE curriculum, if you see, they use capital I. Z is not being used, but still in some textbook they have Z. Okay, so for representing integers, the collection of integers, we can use capital I or Z, capital Z. Okay, so I'll just use capital I here, but you can use Z also. So wherever capital I is there in your 11th standard sets chapter, capital I means it is a set of integers. That means integers means 0, positive numbers as well as negative numbers. Okay. Let's move forward. If you look at the collection of integers, see, integers means from here to here. In that collection of integers, focus on this number. It is nothing but natural numbers. This is actually natural numbers. Now, 0 is neither positive nor negative. Okay, 0 is neither positive nor negative. So, when you see 1, 2, 3, 4, they are all positive integers. So, in some textbooks, I mean some question papers, they will just sometimes give you positive integers. Okay, that means they are natural numbers. Okay, please remember, positive integers means they are nothing but natural numbers. You should remember all this. Okay, so all these are actually what? Maybe if you see here, from here to here, maybe I'll use some other color. Okay, so from here to here, all these are positive integers. And they're nothing but natural numbers. Okay, because what are natural numbers? Starting from 1 and going up to infinity. So positive integers are also natural numbers. Yes or no, everyone? Suvarshita, your camera is not working. Oh, Suvarshita, mom actually messaged me. I'm sorry. Sharian, your camera is not working. Ritya, mom also messaged me actually. And Agnes, since you are not, I mean, there's some network issue from your side, it's okay. Okay, it's fine. Okay. Perfect. So let's okay, sure, no problem. If there's no power, it's okay. Okay. So now let's move forward. So here, this positive integers are nothing but natural numbers. Okay. Please remember that. Okay. Now, one more thing. Look here. I told you 0 is neither positive nor negative. I told you what? 0 is neither positive nor negative. Okay. Now, if you look at these numbers, okay, -1, -2, -3, and so on. If you look at these numbers, okay, if you look at these numbers, they are all negative integers, right? See, here we have positive integers, here we have negative integers. So these are what? Negative integers. Negative integers. Okay, negative integers. Now, if these are negative, see, if these are negative integers, right? I mean, from here to here, if these are negative, see, although 0 is neither positive nor negative, okay, although 0 is neither positive nor negative, but if these are negative integers, no, starting from 0 and going this side, I can call as non-negative, non-negative. They use all this in, I mean, questions. That is why I'm using it. So if this is negative integers, I can say the numbers from 0 to the other side as non-negative integers. Okay. And non-negative integers, if you look carefully, they are nothing but whole numbers. So wherever they use the word non-negative integers, although 0 is neither positive nor negative, but wherever they use non-negative integers, because these are negative, so non-negative will be the other side. Okay. So non-negative integers are nothing but whole numbers. Please remember, non-negative integers are nothing but whole numbers. Okay. Also, if you look into the number set here, if you look at the integers, we can say that all the natural numbers, all the natural numbers are integers. All the whole numbers are also integers. Yes or no, everyone? Yes. All the natural numbers are integers. All the whole numbers are also integers. Please remember that. Okay. Let's move forward. Next, we are going to understand a term called as a factor. We are going to understand the meaning of a factor. Okay. To make you understand the meaning of the meaning of the word factor, I will take one example. Okay. Suppose I have the number 6. Okay. Suppose I have the number 6. See, 6, I can divide by 1, right? 1 6 is 6. 6, I can also divide by 2. 2 3s are 6. 6, I can also divide by 3. 3 2s are 6. Now, with 4, you cannot divide. See, with 4, no, you cannot divide. Okay. Look here. See, if you try, 4 ones are 4, remainder is 2. Okay. With 4, you cannot divide 6. What about 5? With 5 also, you cannot divide. 5 ones are 5, remainder is 1. What about 6? We can divide with 6. Okay. 6 ones are 6. So if you look carefully, one can divide 6 completely. See, when I say completely, remainder should be 0. 1 can divide 6 completely. 2 can divide 6 completely. 3 can divide 6 completely. And 6 can divide 6 completely. 5 cannot divide because remainder is 1. 4 cannot divide because remainder is 2. So if I take the number 6, what are the numbers that can divide 6 completely? 1 can divide, 2 can divide, 3 can divide, and 6 can divide. So all these are factors of 6. So factors of any given number are the exact divisors. What do you mean by factor? They are the exact divisors. Exact divisors means what? Remainder should be 0. Are you all getting or not getting? Yes or no? Very nice. So factors, I will write here. Factors are nothing but, maybe I'll write here. Factors are nothing but exact divisors. Exact divisors. If you look, 1 is dividing, so 1 is a factor of 6. 2 is dividing 6, so 2 is a factor of 6. 3 is dividing, 3 is a factor of 6. 4 is not dividing. See, remainder is coming 2, no? So 4 is not a factor. 5 is not a factor. 6 is a factor because 6 divides. Okay. So factor means they are the exact divisors of any given number. Of exact divisors of any given number. Okay. Any given number. Okay. Let's move forward. Suppose if I take 1. What are the factors of 1 in the chat box, everyone? What are the factors of 1 in the chat? You can just put in the chat, type in the chat. What are the factors of 1? Very good, everyone. The answer is 1. Okay. Only 1 can divide 1. So factor of 1 is 1. Okay. Next, if you take 2, okay, maybe I'll actually write 2 using some other, maybe color. I will write 2 using this, maybe green color, but just 1 minute. I will try to write using green color. So if you take number 2, what are the factors of 2 in the chat? Everyone, what are the factors of 2? Very good. So factors of 2 are 1 and 2. 1 can divide 2, 2 can divide 2. If you take 3, what are the factors of 3? Very good. Factors of 3 are 1 and 3. If you take 4, maybe I'll write 4 here, maybe I'll write 4 using maybe some other color. So all of you tell me what are the factors of 4? Very nice. So nice. Okay. Good, everyone. So factors of 4 are 1. 1 can divide. 2 can also divide. 2 2s are 4, right? And 4 1s are 4. So factors of 4 are 1, 2, and 4. What are the factors of 5? Very good. And everyone, please put in the answer. Even if it is not correct, it's fine. But you please put the answer. Yes. So factors of 5 are 1 and 5. What are the factors of 6? Sharius, can you just check once again? It is 2 also. Yeah, now you have put, yeah, correct. So factors of 6 are 1, 2, 3, and 6. Okay, suppose you take the number 7. What are the factors of 7? Very nice. 1 and 7, right? Factors of 7 are 1 and 7. See, I can keep going, but I'll stop here. I can actually keep going. Okay, with other numbers, but I'll stop here. Okay. Now, if you look here, if you look at this number 2, how many factors are there? Exactly 2 factors are there. If you look at the number 3, exactly 2 factors are there. If you look at the number 5, exactly 2 factors are there. If you look at number 7, exactly 2 factors are there. So those numbers which have got exactly 2 factors, they are called as prime numbers. If somebody asks you what is a prime number, please give this definition. That a number which has got exactly 2 factors, exactly 2, they are called as prime numbers. Okay, so I'll write the definition. So what is a prime number? Prime number means, okay, a number having exactly 2 factor, exactly 2. Okay, a number having exactly 2 factors. And what are the examples of that? Examples of that are 2, 3, 5, 7. And if you keep going, 11. Okay, then 13, 17, 19, and so on. I expect everybody to know all the prime numbers from 2 up till 20. You should know it, okay? So 2, 3, 5, 7, 11, 13, 17, and 19. Okay. So all these are prime numbers up to 20. You must know, okay? So you have understood what is prime number. Next, we have something called as composite number. Next, we have something called as composite number. See, composite numbers have more than two factors. See, prime means exactly two factors. Composite number means has more than two factors. Has a number which has more than more than two factors. More than two factors. And one more thing, everyone. More than two means not 2. More than 2 means 3, 4, 5, 6, 7. More than 2 means greater than 2. Please remember, more than 2 means what? Greater than 2. That means 3, 4, 5, like that. Now, if you go one by one, starting from 1, okay? If you go one by one, okay? If you go one by one, starting from 1 is having only one factor, 2 is having two factors, 3 is having two factors, 4 is having three factors. That means 4 is a composite number because it is more than two factors. Three factors are there. Even 6 is a composite number. Yes or no, everyone? Yes. See, composite numbers means more than 2. 4 is having three factors, so it is a composite number. 6 is having more than two factors, right? It is having four factors, so it is also a composite number, right? See, 2 is not a composite number because composite number means more than 2. Not 2, more than 2. More than 2 means 3, 4, 5, any number of factors. So 2 is not a composite number. Yes or no, everyone? Yes. Perfect. See, all of you, please show a thumbs up every time I ask you whether you have understood or not. It'll be better for me, okay? So examples are 4, 6, and you can keep writing. 8 is also a composite number, 9, and so on. Okay? Okay. Now, if you look at the number 1, how many factors 1 is having? Only 1. That is 1 itself. Okay? 1. See, you cannot say 1 comma 1 because 1 comma 1 is 1 only. Okay, don't write 1 comma 1 there. Okay, both are 1 comma 1, both are same numbers only. We cannot write the same number twice. Okay, so if you take a look at number 1, 1 is having only one factor, that is 1. 1 is having only one factor, that is 1. Okay, for a number to be prime, it should have exactly 2. For a number to be composite, it should have more than 2. I repeat, for a number to be a prime, it should have exactly two factors. For a number to be a composite number, it should have more than two factors. But 1 is having only one factor. That is why I'll write some note points here. Very, very important note points. I will write some note points here. Number 1. Okay. 1 is neither prime. 1 is neither prime nor composite. Okay. 1 is neither prime nor composite. Can you all tell me which is the smallest prime number in the chat box? Which is the smallest prime number?
2.
All of you tell me in the chat box. Okay. It is 2. Okay. See, if you go one by one in order, so 2 is having exactly 2. So that is the first number. So I'll write here 2 is the smallest prime number. Can you all tell me which is the smallest composite number? In the chat, okay? Very good. It is 4, okay? Now, why should we know all this? In one of the board exam, there was a question. Find the HCF and LCM of the smallest prime number and the smallest composite number. See, if you people don't know what is the smallest composite number and what is the smallest prime number, how can you solve that question? You cannot solve. Okay. So 4 is the smallest. I'll write smallest first. 4 is the smallest composite number. Please remember, only if you know these two things, then only you can solve that question, right? So please remember, see, whatever points I'm giving in the class, is going to be extremely helpful. Whatever I'm teaching is going to help you someday or the other. Please remember that, okay? So please follow. Up till here, everyone clear? Yes or no? Perfect. Perfect. Let's move forward. Let's move forward. Okay. So now let's understand factor we have understood. Then next, let's understand what is multiple. Factors we have understood. Next, we are going to understand what is multiples. Okay. See, suppose if I have the number 2. Multiples of 2 means what should I multiply 2 to get the next number? Multiples means, multiples of 2 means, I'll just take 2 as an example. Multiples of 2 means, what should I multiply 2 to get the next number? I can multiply with 1, 2, 3, 4, 5, 1,000, 10,000, anything I can multiply, right? So if I multiply with 2, I'll get 2. Sorry, if I multiply with 1, I'll get 2 ones are 2. Then if I multiply with 2, I'll get 4. And then if I multiply with 3, I'll get 6. And then I'll get 8, then 10, 12, 14, 16, 18, and so on, so on, so on, so on. Multiples of any given number is infinite because you can multiply with any number. 2 multiples are how many? 2 multiples are infinite because I can multiply with 2 with lakhs also. Yes or no, everyone? Yes or no, everyone? Yes, perfect. Next, if I take, for example, 4, what are the multiples of 4? Multiples of 4 means what should I multiply to get the next number? So I can multiply with 1, 4 ones are 4, 4 twos are 8, 4 to 12, 4, 16, 20, 24, and so on, 28, 32, 36, so on, so on. So please remember, multiples are infinite. What about factors? They are not infinite. Factors are finite. We can count, okay? We can count the factors. One more important information about factors are, you take a look at any number. You take a look at any number. That number will have 1 as always a factor, for sure. And the number itself will always be a factor. So for any number you take, 1 and the number itself will always be a factor. See, exception is 1. See, 1 is only having 1 factor. Just forget about 1 as of now. You look at 2, 1 and the number itself. You look at 3, 1 and the number itself. You look at 4, 1 and the number itself. You look at 5, 1 and the number itself. You look at 6, 1 and the number itself. You look at 7, 1 and you take any number, 1 and the number itself. See, for 1 also 1 and the number itself. That is also 1 only. So 1 and the number itself will always be a factor of any given number. Yes or no, everyone? 1 and the number itself will always be a factor of any given number. So I'll write that also. 1 and the number itself is always a factor of any given 1 and the number itself is always a factor of any given number. Okay, remember this. Okay, perfect. Let's move forward. Okay, we have understood what is factors, what is multiples. Okay, next we are going to understand what is HCF. Okay, next we are going to understand what is HCF. HCF. So expansion of HCF is highest common factor. Okay, see, one more thing. First of all, I'm going to give you an idea as to what is a high HCF. Then we learn how to find HCF. Okay, in our syllabus we only have prime factorization method. We don't have any other method. If you apply any other method, see, in MCQ you can apply any method, but for theory question, if you apply any other method, they will give 0. Please remember, you have to apply only prime factorization. I will teach you the prime factorization method to find the HCF and the LCM. First of all, we'll understand what is HCF. Okay. So now I will take some numbers for that. Okay. So let me take number 6. What are the factors of 6? Factors of 6 are 1, 2, 3, and 6. Let me take 12. What are the factors of 12? 1, 2, 3, 4, 6, and 12. Yes or no, everyone? See, if you take 6, factors are this, and if you take 12, factors are this. This is clear, right? Yes or no, everyone? Perfect. Perfect. All of you listen. Please stop writing. See, HCF. We are going to understand what is HCF, right? See, for numbers for which I want to find HCF, first of all, I'm writing factors. Factors I have written, okay? I have written factors, okay? Now, I will see common. See, common is 1, common is 2, common is 3, and common is also 6. Okay? So, I'm explaining the concept of HCF. So I have taken two numbers 6 and 12. I want to find HCF of 6 and 12. So I'm writing factors of 6, I'm writing factors of 12, and I'm taking the common. In this common, which is the highest one? The highest one in this common is 6. The highest one in this common is 6. That is why HCF of 6 and 12 is 6. Okay. So we can say therefore, HCF of, see, HCF of means we'll put a bracket. HCF of 6 and 12 is nothing but 6. Okay. HCF of 6 and 12 is what? 6. Okay. See, this is only for conceptual understanding I'm teaching. Okay. Please don't use this technique in the board exam. This is only for understanding what is HCF, highest common factor. So first of all, I'm writing the factors, then taking the common and finding the highest common factor. Okay. So highest common factor of 6 and 12 is 6. Okay. Now what is a factor? I told you factors are the exact divisors. Yes or no, everyone? Factors are the exact divisors. Yes. Factors are the exact divisors. Now if you look carefully, 1 can divide 6, 1 can divide 12 also. 2 can divide 6, 2 can divide 12 also. 3 can divide 6, 3 can divide 12 also. 6 can divide 6, 6 can divide 12 also. Whatever common factors I have taken, common factors can divide both, right? But 6 is the highest common which can divide both. See, 1 can also divide both, 2 can also divide both, 3 can also divide both. But 6 is the largest number which can divide 6 and 12. Yes or no, everyone? Yes. So HCF is always the largest number which divides the given number. Please remember, HCF is the largest number which divides the given number. Please remember that, okay? HCF is the largest number which divides the given number, okay? So I'll write here, HCF is the largest number which divides the given number. Yes or no, everyone? Yes. See, 1 can also divide both, 2 can also divide both, but 6 is the largest number, okay, which can divide both, or the highest number, okay. Perfect. Okay, I'll reshare my screen. But actually, how will you be able to understand now? How it is possible? I mean, you're joining, in the middle of a class. How will you be able to understand? Maybe you can leave and watch the recording. It will not be possible, okay? It will not be possible for you to understand the concepts now. Okay. I've already taught all the basics. It will be difficult. Okay. You can leave. You can watch the recording. You can connect me with me after the class gets over. Maybe I'll guide you. Okay. I don't want to repeat the same thing again. Okay. It is a waste of time. Okay. So Noah, are you able to hear me? Hello. Okay, let's continue. So you have understood that HCF is the largest number which divides the given numbers. Okay, please remember that. Okay. So now, suppose I'll give one more example. Okay, I'll give one more example. Suppose if I have 9 factors are 1, 3, and 9. Next, I take 18. Factors of 18 are 1, 2, 3, 6, 9, and 18. What are the common factors? 1 is common, 3 is common, 9 is common. Okay. So highest common is 9. Therefore, HCF of 9, 18 is nothing but 9. And if you observe very carefully, 9 is the biggest number or the largest number or the highest number which divides both 9 and 18. Yes or no, everyone? Perfect. 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 Okay. Let's move forward. Let's move forward. And understand the concept of LCM. Okay. LCM is least, or you can also say lowest. Okay. Least or lowest common multiple. Okay. Least or lowest common multiple. Okay. So for this also I'll take some example. Okay. So let me take 2 and 3. What are the multiples of 2? 2, 4, 6, 8, 10, 12. I can keep writing, but it is enough. Okay. For 3, what are the multiples of 3? 3, 6, 9, 12, 15, 18, 21, 24, 27, so on. I can keep writing multiples, right? Yes or no, everyone? Now, what are the common multiples? What are the common multiples if you observe? See, 6 is common. Yes, 6 is common. 12 is common. Next, 18 is common. And if you keep writing, there'll be so many common. Yes or no, everyone? If you keep writing, there'll be so many common. Like, for example, 24 will also be common. If you write few more, 22, 24. 24 will also become common. If you keep writing, so many common will come. I have taken only few numbers. Now, out of all the common, which is the least one? Least one is 6. Least one is 6, right? So, LCM of 2, 3 is nothing but 6. Okay. LCM is least common multiple. Least common multiple is 6. If you observe carefully, see, 2 can divide 6. 3 can also divide 6. 2 can divide 12. 3 can also divide 12. 2 can divide 18. 3 can also divide 18. But 6 is the smallest number which is divisible by both. See, 2 and 3 can divide 6 also, 12 also, 18 also, 24 also, so many other numbers. But 6 is the smallest number which is divisible by both. So LCM is the smallest number which is divisible by both. Okay, remember that also. Okay. LCM is the smallest number, okay, which is divisible. See, LCM is divisible and HCF divides. That has to be very, very clear. HCF divides. HCF divides. HCF will divide. Okay. LCM is divisible. There is a difference. Both are not same. Okay. Divides and divisible both are not same. Okay. Yes or no, everyone? Yes. Perfect. So LCM is the smallest number which is divisible by the given numbers. Okay. LCM is the small which is divisible. Please remember. Okay. So now, next. Yes, tell me. Aviraj, your name is Aviraj, right?
Yes, sir.
Can you rename yourself? There is an option to rename.
Yes, sir.
Like,
Yes, sir.
tell me your doubt. Tell me your doubt.
Also take factors and multiply it, sir.
Sorry, sorry.
Sir, we can also take factors of 2 and 3 and multiply it.
We can. So that is what I'm. See, I have not yet come to that. I mean, I have not yet come to that method. We have. That is what I told now. We have a prime factorization method to find the LCM and the HCF, which is there in our syllabus. This is only for conceptual understanding. See, if I don't teach all these things, Nobody will understand that LCM is the smallest number which is dividing, right? How will they understand? Yes or no? That is why I'm teaching this, okay? To make people understand that LCM is the smallest number which is divisible, I'm giving all these examples. Yes or no? But I will teach you prime factorization method also, okay? Now rename yourself, okay? You can lower your hand and rename. There's an option to rename. You can rename yourself, okay? Okay, let's move forward, everyone. Let's move forward. Next, we are going to understand another very important concept called the fundamental theorem of arithmetic. Okay, so we have something called as fundamental theorem of arithmetic. What is fundamental theorem of arithmetic? Let me write the definition and then I'll explain. Okay, this fundamental theorem of arithmetic. Just 1 minute. Okay, so let's understand what is the definition. Okay, it says the fundamental theorem of arithmetic says every composite number, see, for example, I'm taking 6. 6 is a composite number. Every composite number can be expressed or factorized as a product of primes. Every composite number can be expressed or factorized as a product of primes. First, let's understand only up to this point, okay? Let's understand only up to this point. See, if I have 6, I can divide by 2, and 2 threes are and 3 ones are. So I can write 6 as 2 into 3. Now, I have already told you that you all must learn all the prime numbers up to 20. So 2, 3, 5, 7, and so on. Always, I request everybody to go in order. So 6, I'm dividing by 2 first. Yes, because 6 is divisible by 2. And then 3, see, 3 is not divisible by 2. That is why I go with 3. 3 ones are 3. Now, there are some students, what they will do? They will start dividing by 3 itself. 3 twos are and 2 ones are. They are also right. They are not wrong. Okay. But I request everybody to go only by this. I mean, order, you have to go in order. Okay. So 6, I can also write as 3 into 2, right? Both are correct, no? 2 into 3, 3 into, both are correct only, right? Yes or no, everyone? Yes. No, actually, for today, you can just leave for the class. I mean, it will be very difficult for you to understand. You have joined, I mean, after 40 minutes. Okay. It will be very difficult. Okay. You can watch the recording. You can connect with me maybe after the class gets over. Not after the class, maybe tomorrow you can connect with me. I can just guide you as to how to go about if you want to join the classes. I mean, it is not possible for you to understand. Okay. It will be just a time waste. So you can leave for the day. Let's connect tomorrow. You can just message me on WhatsApp. Let's connect tomorrow and I'll guide you as to how to go about. Okay. You can leave. Okay. Okay. Sorry. Sorry, everyone. Just 1 minute. So I wrote 2 here, right? So 6, I can write 2 into 3 or 3 into 2. Correct? So now, every composite number, 6 is a composite number, can be expressed or factorized as a product of prime. See, 6 I have written as 2 into 3, right? Both are prime numbers, right? 6 I have written 3 into 2. Both are prime numbers only, right? So every composite number can be expressed as a product of primes. First part is clear now, everyone? Yes or no? First part is clear, no? Perfect. Second part. And this factorization is unique. When you do the prime factorization of 6, you look, here also 2 is there, here also 2 is there, here also 3 is there, here also 3 is there. See, prime factors are unique, right? Order is changing. But prime factors are unique only, right? Yes or no, everyone? Yes or no? prime factors are unique. Order is changing, but prime factors are unique. Okay, unique. So that is what they've written, apart from the order in which the prime factors occur. So prime factors may occur in any order, but they will be unique. If you take 6, always 2 and 3 will only come. Order may change, but always 2 and 3 will only come. Yes or no, everyone? But I request everybody to follow this order only. Don't follow this order. This order I have written just to make you understand what is this fundamental theorem of arithmetic. Okay. So every composite number can be expressed as a product of primes, and this factorization is unique apart from the order in which the prime factors occur. Clear, everyone? Perfect. Perfect. Now we are going to make use of this fundamental theorem of arithmetic, which is nothing but actually the prime factorization, and find the HCF and LCM, and that is only there in our syllabus. Okay, that is only there in our syllabus. Okay, so let me take one example. Just give me 1 minute. Okay, 1 minute. Just 1 second. Yes, good, Aviraj. I will start. Just 1 second. All of you just wait. You just try to recall whatever we have learned. We'll continue. Just 1 minute. Okay. It's okay. Here it is. Just 1 minute. Okay. So let me share my screen. 1 minute. So I'll share my screen. Okay. Aviraj, are you able to see my screen? The white screen, are you able to see? Aviraj, are you able to see my screen? Okay, let's continue. Okay, so now we are actually going to use the prime factorization method. Okay, we are going to use the prime factorization method to find the HCF and LCM. And you have to use only this method to find the HCF and LCM. If it is for 2 marks or 3 marks, okay, you have to use only this method. You cannot go for any other method. Okay. Okay. We'll actually focus on that also, Sanskriti. Just 1 minute. Aviraj, you're able to see my screen? Okay, okay, okay. Okay, no problem. Okay, let's actually continue. Okay, let's continue. Okay. So now, suppose I have the number 8820 and 1008. Okay. And I want to find the HCF and LCM by this method only. Okay. We have to find the HCF and LCM of these two numbers by prime factorization. All of you, please focus, because once you understand this question, you can solve any other question. First, you understand. I have taken big numbers so that you get all the basics right. Okay. See, whenever you want to find the HCF and LCM by the prime factorization, first of all, just write the numbers 8820 and 1008. Okay. Write both the numbers. Okay. Then take any one of the numbers. Maybe I'll take the first number 8820. Okay. You take any one of the numbers. I'll take 8820. Okay. I told you that you all must know all the prime numbers. I mean, up to 20. So 2, 3, 5, 7, and so on, right? Yes or no? I will always start with 2. I will check with 2 first. This is divisible by 2. So I'll divide with 2 first. Look how I'm doing it. 2 4s are 8. 2 4s are 8. 2 1s are 2. And 2 zeros are 0. Next. Look. 2 2s are 4. 2 2s are 4. 2 5s are 10. Am I right? Yes or no in the chat box, everyone? Am I right? Yes or no in the chat box, everyone? Am I right up till here? Am I right? Some people say yes. I'm actually not right. I cannot write 225 here. It will become 2205. This is what majority of the people makes a mistake in this. Okay, majority, I'm telling you, majority. I was not right. Okay, I was wrong. Okay, it will be 2205. Let me explain. Okay. See, suppose if I have maybe, okay, suppose I have the number. Let me actually explain this concept. See, suppose if I have the number 212. Okay, first of all, let me take the number 6. See, when I'm dividing 2 3s are, that means if I multiply these two, I should get this. See, 2 3s are 6. So if I multiply both of them, I should get this, right? Now, if I do like this, okay, see, if I do 2 1s are 2, 2 6 are 12. If I do like this, 16 2s are 32, but I am getting 212, which is not correct. See, if I do 2 3s are, if I multiply, I should get this. If you do 2 1s are 2, 2 6 are 12, 16 2s are 32, not 212. So this is not correct. Okay. This is not correct. So now, whenever you're doing the division, you start from the left side. 2 1s are 2. 1 is not divisible, right? 1 is not divisible. 1 is not divisible by 2. So to take the next digit, no, to take the next digit, first put a 0. Okay, that is a rule. You have to put a 0 first. And then 2 6 are 2. Why are we putting a 0? To take the next digit. Yes or no, everyone? Perfect. Look, 2 5s are 10, 2 3s are 6. And then we keep going, okay? So always remember, whenever we want to take 2 digits at a time, we have to put a 0 first, then only take the next digit, okay? That is extremely important. Okay, so let's actually now coming back to this. Look here. See, look here. All of you, please focus. Don't write anything. I mean, don't do anything. Just listen. Please, my humble request, don't do anything. Just listen. Okay, 2 2s are 4, 2 2s are 4. 1 is not divisible. So to take the next digit, you have to put 0 first, and 2 5s are 10. Now, this number is not divisible by 2. This number is not divisible by 2. How do I know a number is divisible by 2 or not? To check if the number is divisible by 2 or not, look at the units place digit or the ones place digit. If it is 0, 2, 4, 6, 8, then the number will be divisible by 2, otherwise not. So it is not divisible by 2. What about 3? To check if the number is divisible by 3 or not, we find the sum of the digits. Sum of the digits. See, here I have 2205, na? So find the sum of the digits. In a number, no, these are called as digits. So find the sum. So if you find the sum, it will come 9. Now 9 is divisible by 3. That is why the number will also be divisible by 3. To check if the number is divisible by 3 or not, you find the sum of the digits. If the sum of the digits is divisible by 3, then the number is divisible by 3. See, all these are very basics. I mean, you should have actually learned this in 6th or 7th. Okay. Anyway, I have actually told you. So I will do with 3. 3 sevens are 21. See, initially we can take two numbers. Now, even if you want to put 0 here, no problem. Because if you put 0 before a number, no change, right? So 3 sevens are 21. Carry over 1. 3 sevens are 21. Maybe you can write here. 3 threes are 9. Carry over 1. And 3 fives are 15. Clear till here? Next, check with 3 again. So 7 plus 3, 10. 10 plus 3, 10 plus 5, 15. If we can do with 3 again. So 3 twos are 6, 3 fours are 12, and 3 fives are 15. Clear? See, don't check with 2 again because 2 is gone. I mean, once it is not divisible, later also it will not be divisible. So check with 3 again. So 2 plus 4, 6 plus 5, 11. So 3 not possible now. What about 5? This is divisible by 5. How to check whether a number is divisible by 5 or not? If the ones place digit or the units place digit is 5 or 0, then the number is divisible by 5. If the ones place digit is 5 or 0, then the number is divisible by 5. So see, 5 fours are 20 and 5 nines are 45. Now this is not divisible by 5. We can very well see. So 7 sevens are 49. Clear now, everyone? Now, in your 9th standard, you have learned powers, right? Powers, exponents and powers. See, suppose if I have 2 into 2 into 2 into 2 into 2, I can write 2 power 5. 2 in, see how many times are we multiplying? 5, so power 5. Suppose I'm doing 3 into 3 into 3 into 3. I can write 3 power 4. Okay, I can write 3 power 4. Suppose I have 7 into 7 into 7 into 7. So 7 power 3. Yes or no, everyone? Yes? Perfect. So now, similarly, if you look at 8820, I've got 2 into 2. So I can put 2 power 2. Yes or no? Next, I have got 3 into 3. So I can put 3 power 2. I have got 5 only one time, right? Only one time. So I can put 5 power 1. And 7 I have got 2 times. So, clear now, everyone? Perfect. Same way, can you all take this number 1008 and just try to do like this? Just try. You don't tell me the answer, just try. Take the number 1, okay, take the number 1008 and do the prime factorization. Try for yourself first. Just try. See, the prime factorization method and the conceptual method, both are different. In the conceptual method, we have just understood what is HCF and LCM. Don't apply that here. Will learn, okay, actually. We'll learn. Very good, Aviraj. That's no, Aviraj, you have missed something. No, you have not missed. It's correct. Good. Okay. Let me do it also. First of all, you all try. Some people have put the answer also. Very nice, everyone. You're all of you are right. Let me do it. All of you listen. Those who have done also listen. See, first of all, I'll start with 2. Why am I starting with 2? Because this is divisible by 2. The ones place is divisible by 2. So look, 2 fives are 10, 2 zeros are 0, and 2 fours are 8. 2 2s are 4, 2 5s are 10, 2 2s are 4. 2 1s are 2, 2 2s are 4, 2 6 are 12. 2 6 are 12, 2 3s are 6. With 2 not possible, 3 possible. 3 2s are 6, 3 1s are 3. Okay. 3 7s are 21 and 7 1s are 7. Clear now, everyone? So I can write 2 to the power 4 into 3 to the power 2 into 7 to the power 1. Okay. So now I'll go to the next page. I will take only this much part. Okay. I need some space. Okay. So that is why I'm going to the next page. See, I wanted to find the HCF and LCM of these two numbers. Okay. So what I have done, I have taken the numbers and expressed the numbers as a product of primes using the fundamental theorem of arithmetic, which says that every composite number can be expressed as a product of primes irrespective of the order in which the prime factor occur. Okay. Order may change, but the prime factors will not change. Okay. Now, to find the HCF and LCM by the prime factorization method, I mean, if you just remember the concept and do it, you'll always get it wrong. Now, forget about the concept which you have learned. See, the concept which you have learned about HCF is this one. HCF is the highest common factor. I mean, I have explained this. And LCM is the lowest common multiple. Forget about this method as of now. Whatever we have learned here, you forget. Because the prime factorization method is quite different. If you try to recall that, you'll always make a mistake here. Okay. So prime factorization method is quite different. To find the HCF of these two numbers or any two numbers by the prime factorization method, what we do now, first of all, we see the common prime factor. See, 2 is common, 3 is common, and 7 is common. I repeat, whenever you want to find the HCF using the prime factorization method, first see the common prime factor. First see that. Okay. First write that 2, 3, and 7. First write that. And put the lowest power of the common prime factor. See, lowest power of this 2 is 2. Lowest power of 3, actually both are same power, so we can put 2. And lowest power of 7 is 1. I repeat, whenever we want to find the HCF using the prime factorization method, we first of all write the common prime factor and put the lowest power we have to put. So 2 power, lowest power is 2, 3 power 2, and 7 power 1. What is 2 power 2? 2 power 2 means 2 into 2. What is 3 power 2? 3 into 3. What is 7 power 1? 7. Okay. Now, if you multiply all of these, okay, 2 2s are 4, 4 3s are 12, and 12 is 36. 36 into 7, if you do right, you'll actually get the answer. It will be 252. Are you all getting? Yes or no? So what we are basically doing is, please remember, sometimes they're asking this also. To find the HCF, we are doing this, okay? In the NCERT, they have given this word, but this word is this statement is very confusing, okay? So product of the smallest power. So you know what, actually, when people read this, they think that we have to multiply the powers. It says product of the smallest power of each common prime factor. So when you read this, it's a bit confusing. That is why I'm telling you, first you take all the common prime factors and put the lowest power. Okay, that is what this sentence also conveys. This is exactly there in the NCERT. Product of the smallest power of each common prime factor. So you take each common prime factor, put the smallest power and multiply. You'll get the answer of HCF. Yes or no, everyone? Perfect. Okay, next. To find the LCM, of 8820 and 1008, we don't have to take anything common. We have to take all the prime factors which are there. Now, if you look at the numbers, two numbers, what are the prime factors which are there? 2 is there, 3 is there, 5 is there, and 7 is there. Okay. For LCM, no need to take any common. Although LCM is least common, common is there, but there is no common in the prime factorization method. In LCM, there is no common in the prime factorization method. We have to write all the prime factors which is there and put the highest power of each of them. 2 highest power is 4, 3 highest power is 2, 5 highest power is 1, and 7 highest power is 2. Yes or no, everyone? So what we are doing is, while taking the LCM, we don't take common. We have to write all the prime factors and put the highest power. So this is what is given in NCERT. Product of the greatest power, highest power of each prime. See here common, we are in a HCF we have to take common and put smallest power. In HCF we have to take common and put smallest power of each of them. Whereas in LCM we have to take every, no common, every prime factor we have to take and put greatest power and then multiply. Yes or no, everyone? Very, very, very important. I mean, if you understand this question, you can solve any question. Otherwise, you will keep getting confused. So 2 to the power 4 means 2 into 2 into 2 into 2. 3 power 2 means 3 into 3. 5 into 7 into 7. If you multiply, you will actually get 35280. Okay. Is it clear, everyone? Very good. Now. Suppose if I have two numbers, okay? Suppose I have two numbers, okay? Let it be A comma B. Okay. Suppose I have two numbers, let it be A comma B. You can take X comma Y also. Okay. Suppose I have two numbers A comma B. If you find the HCF of that two number, A comma B, and multiply by the LCM of the same two numbers A comma B, I repeat, I have two numbers A comma B. A can be maybe 4, B can be 6, any number. If I have two numbers A comma B, HCF of the two numbers A comma B into the LCM of the same two numbers A comma B will be equal to the product of the two numbers always. It is only applicable for two numbers. Okay. Suppose if you take X and Y as the number, HCF of two numbers X comma Y into the LCM of the same two numbers. Don't take A comma B here. Number has to be the same, X comma Y only. Will be equal to the product of the numbers. Are you all getting or not getting? Yes or no? So now, if you look here, I have taken two numbers as this and this, right? Yes. Maybe I'll actually shorten this. I'll take a pic of this. So you will find that, okay, you will find here that HCF of 8820, 8820, comma 1008 into LCM of the same two numbers 8820, comma 1008 will be equal to product of the two numbers. See, what is the HCF we got? 252. What is the LCM we got? 35280. This is LHS, okay? This is left hand side. This is LHS, okay? So if you multiply, you'll actually get 8890,560. Now come to RHS. See, RHS is this. RHS is this. Viraj, mute yourself. You have a doubt? Yes, thank you. See, RHS is this one. So if you multiply this one, again, you'll get 8890,560. So always remember, if you have two numbers, if you find the HCF and LCM, if you multiply, that will be equal to the product of the two numbers. Yes or no, everyone? Perfect. Perfect. I will take one more example, then I'll give you some questions, okay? I'll take only one more example, okay? And then I'll give some questions to you, okay? Look, let me actually get some water and come. Okay. Suppose I have the numbers 6 and 20. So I'll write 6 and 20. Then I'll take 6. 2 3s are 3 1s are. So 2 to the power 1 and 3 to the power 1. I'll take 20. 2 tens are, 2 fives are, 5 ones are. So 2 to the power 2, 5 to the power 1. Okay, what do we do in HCF? In HCF, we take first of all common. Only 2 is common, see? And put smallest power, 1. So answer is 2. To find the LCM, what do? We don't take common. Every prime factor you write 2, 3, 5 and put greatest power 2, 1, 1. So 2 to the power 2 means 2 into 2, 3 into 5. So if you multiply 2 to the 4, 4, 3 is 12, 12, 5 is 60, answer is 60. So HCF is 2, LCM is 60. Yes or no, everyone? Now look, HCF of 6, 20 into LCM of the same two numbers 6, 20 will be equal to 6 into 20. Let's prove this. HCF of 6 and 20 is 2 and LCM of is 60. So if you multiply 2 and 60, you'll actually get 120. And here also, if you multiply, you'll get 120 only. Yes or no, everyone? So this is always true for two numbers, okay? Now let me take three numbers, okay? Then I'll give you a question. Suppose I have three numbers, 6, 72 and 120. So what do? But for three numbers, that is not applicable. That HCF into LCM is equal to product. See, that is not applicable for three numbers. But we can find HCF and LCM of three numbers, okay? So let's see. So 6 means I can write 2 to the power 1 and 3 to the power 1. 6 I have already done, so I'm not doing it here. 72 I'll do. See, 2 3s are 6, 2 6 are 12. 2 1s are 2, 2 8s are 16. 2 9s are 3 3s are 3 1s are. Okay. So I can write 72 is equal to 2 to the power 3 into 3 to the power 2. Clear, everyone? Next 120, you take 120 and do the prime factorization. Take 120, 2 6 are, 2 3s are, 2 15, 3 5, 5 1. So 2 to the power 3, 3 to the power 1, 5 to the power 1. To find the HCF, first of all, see common. Only 2 and 3 is common, right? See, 2 is present everywhere, 3 is present everywhere. So write the common first and put smallest power 1 and 1. See, smallest power of 2 is 1 here and smallest power of 3 is 1. That is why. So 2 into 3, answer is 6. Clear, everyone? HCF is 6. What is the LCM? LCM, we don't take common, okay? Each prime factor you write down. 2 you write down, 3 you write down, 5 you write down. And put highest power. Put highest power. So 2 to the power 3 means 2 into 2 into 2, 3, okay, 5, okay. So if you multiply this, 2 to the 4 and 4 to the 8, so you'll get 8, 8 into 3 into 3 into 5 you do, you'll actually get 360. Okay, are you all getting yes or no? So can you all try this question? You have to put answer only in the chat, okay? And you have to actually put only the option A, B, C, D, okay? Do this question, everyone. This was a question asked in one of the board exams, okay? Do it, everyone. And please don't unmute and tell me the answer. I mean, other students are trying. If you tell the answer, I mean, it will just disturb the flow. Okay. So do it and just tell the answer only in chat. Sharon, the power did not come yet. And I think what is happening to you? I mean, you keep switching on the video, switching off the video every time. I mean, what is happening? And why did you leave the last class 5 minutes? I mean, 9:30 means 9:30 you will leave. Huh? Actually, I should leave 9:30 because I am tired. You are so tired, huh? Like, I mean, you left at 9:30 itself.
My camera's battery is
Okay, camera is also, so you charge your camera battery. If your camera is running on a battery, you charge your camera battery. You know na that today's class is there.
just
Yes.
no
Yes,
problem.
Somil, Prince, Shaurya and Aisha, all of you right. Aryan right, Sanskriti right, Stuti right, Janav right. Very nice. Okay. See, Naitik, you should not give excuse, okay? And nobody should give excuse. Okay. See, I can also give excuse. I can also say there is no chat. See, you'll actually, some students actually who have attended ninth class, they would have seen, even if the power goes off, I will take a class. I can also give excuse. There is my internet is not working properly. Let's cancel the class. Shivani right, Meenal right, Yogesh, all of you are right. Prisha, you are not right. Check. यही होता है. This is what happens when we are not careful. We make silly mistakes, just as she has done. Aditya right. She has got the right answer, but still, I mean, she has not looked at the options properly. Okay. Be very careful, Prisha. Yes, you are right now. Okay. So almost everybody has given the right answer. Aviraj, you have not got the answer. Very good, Aviraj. You are right. Very good. So everybody has got the right answer. Some people have not even tried. Amurtha, you are not right. Okay. Let's understand everyone. And you are nowhere close also, Amurtha. Okay. No problem. Let's understand. So we have to find HCF and LCM by, I mean, we'll see here we can use any method because it's MCQ, but I'll use prime factorization. So take 12. So 12, 2 6 are, 2 3 are, 3 1s are. So I can write 2 to the power 2, 3 to the power 1. I will take 21, 3 7s are, 7 1s are. So 3 to the power 1, 7 to the power 1. Okay. I will take 15, 3 5s are, 5 1s are. So 15 means I can write 3 to the power 1, 5 to the power 1. What do we do in HCF? In HCF, we take first of all common. Is 2 common? No, 2 is here, but 2 is not here and here. So 2 is not common. 3 is here, 3 is here, 3 is here. So only 3 is common. Even 7 is not common. 7 is here, but not here and here. So only 3 is common. So to find HCF, using the prime factorization method, we first of all take common and put smallest power. So answer is 3. Okay. So if you look at the options, see, first of all, they are given HCF, then LCM. So HCF is 3. See, 3 is present here and here. So these two options are ruled out automatically. Okay. They are ruled out automatically. Okay. Now, if you look carefully, I mean, we need not find the even LCM. See, because we know that LCM is the smallest number which is divisible. Can 140 be divisible by 50? No, right? Even actually 12, if you take 12, okay, can 12 divide 140? No, right? So this will also be ruled out. Like this also you can do. If you know the concept also, you can, by concept wise also you can do. Yes or no, everyone? Yes or no, everyone? Yes, you can apply concept here also. But I will do the method LCM of 12, 21, and 15. You write all the prime factors 2, 3, 5, 7. We have 2, we have 3, we have 5. All the prime factors you write and put highest power of each. See, 5 power 1, 7 power 1, 3 power everywhere 1 only, right? So highest power is 1 only. 7. So you multiply. If you multiply, you'll get 420. So the answer is option C. Majority of the people have given the correct answer. Very good, everyone. Okay. Okay. Is anybody having a doubt? You can unmute and ask. If anybody is having a doubt, you can unmute and ask. Okay. Let's move to the next question. Can you all tell me the answer to this question in the chat box quickly? Very good. All of you are right. Everyone is right. Very nice. All of you just put the option alone. Everyone is right. What about other people? I mean, Naitik, what is that? You never actually, I mean, what is the answer? Naitik, what is the answer?
They have given the answer in the chat box. See, 2.
Yes, good. Now you have to, yes, correct. Yes. So the answer is option C. We have already discussed that prime number. Exactly 2 factors are there. So option is C. Clear, everyone? Okay, next question. Can you all tell me the answer very quickly? Okay, don't take a lot of time. Tell me. And next class we'll discuss a lot more questions. Please revise all the concepts and come. Don't jump into the class just like that. Nobody should come to the class just like that. You have to write complete notes, revise and come. Okay. Don't waste your time. Okay. Oh, some people have put in the answer also. No. Prince and Aviraj, not right. Prince and Aviraj, not right. Stuti, right. Very good, Stuti. It's correct. Aisha, correct. Aryan, not correct. Yugesh, not correct. Somil, not correct. Shari is not correct. See, this is where the presence of mind comes into picture. I mean, other people are not, I mean, mentally they're, I mean, somewhere they're thinking of something else. This is where the presence of minds. Amruta, very nice. You are right. Somil, not right. Naitik, very nice. Viraj, not right. Prince, not right. Naitik, right. Very good, Naitik. Very nice. Very good presence of mind. Okay. Although your camera is switched off, very nice. Okay. Sanskriti, not right. Sharan, very nice, Sharan. Somil, not right. Oh, you're trying all the combinations, right, Somil?
Yes, sir.
Concept से apply करो, हो जाएगा, answer आएगा. Shivani, correct. Okay, let's understand. Everyone stop writing anyway. It's time up also. I mean, most of you, I mean, you are ready to actually leave. So I'll discuss this question. All of you stop writing first. Listen, don't put the answer now. All of you can stop typing. Stop means stop. Just listen. The question says LCM of smallest two-digit composite number. Not smallest composite number, smallest two-digit composite number. So see, if it was smallest composite, Jana, why did you put the answer now? I told you don't put, I mean, you're doing unnecessary things. I mean, you don't understand English. See, when I say something, everyone, please follow. I mean, I'm saying something, you're doing unnecessary things. I mean, don't go against it, okay? So, smallest two digit. I told you what is digit also in the class. Today, I told you what is digit. So, smallest two-digit composite number. See, the smallest two-digit number is 10, first of all. And 10 is also a composite number. How do I know? If you take the factors 1, 2, 5, and 10. So smallest two-digit composite number is 10. Majority of the students did not even read this two-digit number. They just took composite number and then solve the question. So be present. Okay. And the smallest composite number. Okay. So smallest composite number is 4 only. Okay. So LCM of that we have to find out. Okay. So 10, 4. 10 means 2 into 5, 2 to the power 1, 5 to the power 1. 4 means 2 to the power 2. Okay. LCM of 4 comma 10 is equal to, see, if you look actually in LCM, we don't take any common, right? We write all the prime factors 2 and 5 and put highest power. So 2 to the power 2 means 2 into 2 into 5. Okay. So 2 to the 4 for 20. Answer is option C. 20. Yes or no, everyone? Yes. Rithya, understood?
Yeah, now understood, sir. Now understood.
Okay. So one more thing. Don't leave anyone. First of all, listen. I mean, my humble request every time I'm repeating, please write the class notes within 24 hours. Please do it, everyone. Don't wait for your parent to actually interfere and ask you whether you have done it or not. You are matured enough. You are going to write board exam. And you are not studying for anybody else, but for yourself. Please remember that. Okay. You are not going to do it for me or for your parents. You are going to do it for yourself. Your future will become bright. Okay. Realize that. Still, there are students who are not even realizing that. So write the class notes. It is not that you have to do it today itself, now itself. Tomorrow you do it. But by tomorrow it should be complete anyhow. And then before you join the next class, you revise and come. And whatever questions we have done, see this question, some of you have not got it correct. You practice. First of all, you practice the questions which we have done here itself. You practice questions from here itself first. Without saying you practice. Revise the concepts. And then only you take questions from any other book or previous years. Okay. And if you have any doubt, always feel free to message me on WhatsApp. Definitely I'll respond. So with this, I'll stop. If anybody is having a doubt in whatever I have discussed so far, you can wait and ask. If you don't have a doubt, you can leave. Thank you so much, everyone, for joining in. Take care. Bye-bye and good night.
Thank you, sir.
Thank you, sir. Bye,
Thank you,
sir.
sir.
Thank you,
Thank you, sir. Bye.
Thank you, sir.
Thank you, everyone. Thank you, everyone.